Okay, so we will start. We actually have done in the earlier lectures what I had actually discussed about the network and also talked about the manual telephony. And as usual, manual telephony actually does have its own problems. Basically the problems which one will face is because of humans. So remember, there is a telephone operator which sits in the exchange and which actually he or she will manually connect the connections between various people. The person will also interact with the corresponding users or the telephone owners. So all communication essentially will depend on that particular person. Now if that person is not in a good mood, so maybe he or she may not pick up the phone. If he or she cannot see the light which is blinking, which is the indicator that the handset actually has been taken off the cradle. So that indication, if he or she is not able to see, he just ignores. In that case, you want to make a call, but you cannot talk to the person, you cannot tell him to which place you want to make the call. So this kind of inefficiency actually can come in. So the human problems or human behavioral problems actually will creep in actually, and then you will have a possibility that errors in CDR, the call detail record. So you have to pay for, say, per minute kind of charges to the telephone company for making a call, but the person there actually had made a wrong entry in the register itself. So when the bill will come, there is going to be a problem, and then of course there will be, you have to fight with the telephone company for rectifying the bills. So the CDRs has to be as accurate as possible. There should not be any error which should come in, and this can always happen when a human is recording it on a sheet of paper. If that sheet of paper gets lost, it's torn, is worn out, or maybe rats will eat it, then of course the whole bill cannot be generated. So those kind of issues will come in, and of course the biggest problem is there is no privacy. What actually it means is that the telecom operator can actually listen to your communication. So when you are making a call, she has set up a call between two people. Now you should not expect any privacy, because he or she can listen to what you are talking to the other person. Now that's, I think, one of the biggest problems. In fact, analog telephony, that's a problem, but manual telephony, this is a bigger problem, because nobody has to go and do something, but telecom operator itself knows that what you are talking about. And of course one gentleman, this of course is anecdote, we do not know whether it was right or wrong, but it has been mentioned at various places that this was an anecdote. The gentleman named Alman Brown Strowger, and of course most of the people know as A.B. Strowger, is a person who is responsible for removing this manual telephony and then of course putting all these people, operators, out of the job. Of course they must have moved to the different jobs, and gave birth to something known as automatic telephony. Okay, automatic APABX, automatic electronic private branch automatic exchange. And of course he actually filed a patent for this in 1891. Idea was basically conceived in 1888. And of course the story goes that this guy was not an engineer, but he was also working as an underwriter at some point of time. So underwriter are the people who was trying to provide insurance to the people. Okay, they underwrite whatever is the commitment for a person against the liabilities. So whenever the calls used to come to this person for the underwriting business, the clients used to call him, Mr. Strowger, but the operator, his office actually was connected through a phone, and the telecom operator, the exchange operator there, she was a lady and her husband was also a underwriter. She was mostly actually routing all the calls which were coming for Mr. Strowger to her husband, and of course that is where it pinched actually to him. That is the way the story goes, and then he decided that he will build up the automatic exchange, and that is when of course the birth of Strowger exchanges actually has happened. He started in 1892 after filing, this is the patent filing date. This patent of course you can search even on the net. He started a company in 1892, it is a quite long time back. This company's name was Strowger Automatic Telephone Exchange Company. And of course, he deployed his first exchange, which was with 75 subscribers with a capacity of 99, maximum possible subscriber in the automatic exchange, and he started this also in 1892 itself. And ultimately he actually sold it off, this particular patent, at some point of time to another company, and Bell Laboratories ultimately acquired that patent later on, and at that time when it was acquired, it was in 1916, that time the patent was acquired for $2.5 million, which was a humongous sum, for which the simple patent actually was acquired by Bell, which was a major telephone service provider in US at one point of time. But now most important thing, I actually mentioned in the previous lecture that you have to tell in some by some method to the switch what you intend to do. When you are going to receive a call, the switch has to tell you that a call is coming to you. So there is a signaling which has to be there. So how this signaling can be implemented in this kind of system, that is an issue. So in fact, when the manual telephony is there, I can always say I would like to talk to so and so gentleman who resides in this particular city. So you kindly set up a call for me, and once the call is set up, give me back a call and connect me, I will talk to him. So that is the way that you are doing signaling with the exchange, but here it is automatic system, how you will do this. And remember, that time we were not having sophisticated computers. So this was actually built with electromechanical system. It basically used electromagnets, springs, ratchet wheels, that is the concept which was used, and the relays which were used to essentially program it technically. So let us see how this was actually done. So for signaling purpose, one of the major thing, in fact this was in use for a long time, the pulsing, the keep actually come at this point of time. So remember, if you have seen the older phones of this kind, so when you want to dial 1, so last one will be 0. So when you want to dial, you will put a finger here, come all the way here and just leave it, it goes back. It actually generates a train of pulses. It generates a train of pulses which are calibrated. So most of the equipments, these mechanical kind of equipments have to be calibrated. These pulses were the mechanism by which digits can be communicated to the exchange, and there was a reason why this was done, because each one of them will cause an electromagnet to get activated, which will cause a ratchet wheel movement by one step. So number of pulses means those many steps will be applied and it can actually move. So that was the basic principle, that is the reason why this actually got invented with the Strowger exchanges. So that was the mechanism by which communication was happening. The reverse communication from exchange to the user was happening only by ringing thing. Okay. So, it was not telling that who is calling you. So, earlier the telecom operator used, exchange operator can actually tell the destination guy that a call is coming from so and so gentleman, would you like to take it up. In this case this was not feasible. So, there was no caller ID thing implemented in this thing, but most important thing, there is no telecom exchange operator participating. So, secrecy is kind of guaranteed unless somebody goes there and actually connects his headphone, insert it into the circuit and listens to what you are communicating. Till that time it remains secure, and of course it works automatically. So, that was the beautiful thing. So, the basic components, in fact, for 1 you will be using 1 pulse, for 2, but for 0 you will be using 10 pulses. For 0 there was nothing like a 0 pulse, because unless you have provided a pulse, your circuit will remains on a home location and it actually moves depending on the number of pulses. So, 0 was always in the end. Okay. So, now let us see what are the basic stuff which was actually used to build the Strowger exchanges. In fact, there were only 3 components which were used. So, one of them is uniselector, second one was two motion selector, and third thing was director. So, these were the basically the components which were pretty much kind of standard. The combination of these were actually used to build up these Strowger exchanges. It is basically a mechanical system. So, normally for a uniselector you will have a ratchet wheel of this kind. So, you can actually see this is hinged here, so it can rotate. Okay, it can rotate only in one direction, and normally there is a stick which is attached to this. So, there is a central point where the current will come, and then you will have the connections, the various points. So, it starts from 1 and goes till 0, and there is a home location. So, when the call, there is no call going on, this should always rest at the home location, and depending on the requirement you will give the pulses to the control circuit and it will move and make a connection to that particular path, which will be decided by the number of pulses which have been inserted into this system. And once the first round of that dial actually is over, in the second round there will be a relay circuit by which it can be now the next sequence of pulses can be fed to the next circuit and so on. Okay. And similarly, when the call is going on, that time a rotary counter will start and counter will stop when the call is over. This is all being managed through relays. So, even metering was automatic in this case. Now, how this ratchet wheel is going to work? It is a basic element thing I am actually showing. So, when I am showing this reference, this means it is a rigid element, it cannot move. So, usually there will be a hinge, this kind of mechanism, and this is a spring. And with this kind of a loop. So, whenever I am going to have this, in fact we call it as a return type of uniselector. So, here you are going to apply the electrical pulse. Once the pulse is applied, this will pull the arm downward and this will engage with the next teeth, and when the pulse is over, this will return back because of the force of the spring, and this ratchet wheel will rotate by one step. You put more number of pulses to rotate those many number of times. So, if you would have been there in the exchange, you will actually see hear the sound like tick tick tick. So, every time there is a ratchet wheel moves, there is a click kind of sound which will come up, and of course this should not go back unless you wanted to push it back to the home location. So, for that you will put a device which is again hinged. we call it detent. So, this was the basic mechanism which was used, and of course, you need to have a spring. This is also hinged, so you need to have a spring here also. So, this is another spring, this is another spring which is used, and that is how the uniselector will actually work. So, given the number of pulses, it will go from home location to that corresponding point, and if you want to push it back to the home location, the idea is that you again rotate it completely till it comes back to the home location. So, it can rotate continuously, and this is through a brush, it is this particular electrical circuit is connected. So, this is the input line from the guy, this is the destination side. So, you can actually put 1 to 10 switch. So, remember this is like a switch which has 10 outputs and 1 input, and one of those 10 outputs, only one of them can be connected to the input. This of course equivalently can be done through a electrical switch like this also. But of course you will have 10 of these, but depending on how many number of pulses are coming, each one of them, one of these has to be switched on. So, here this is done through a electromechanical system. So, this is also counting in that sense, that logic was inbuilt. Second kind of thing also which was built was, because this is only connecting 1 to 10 users, okay. There is another kind of device which was used, which is known as 2 motion selector. Of course, I think none of these equipments are in use nowadays, you can only find them in the museum. The second one was something like this. You will have this particular array of contacts are there along this circle. So, there is one place where there is a split, so that that arm which is being hinged onto the central axis, when it is in this location outside in this slit, it can move upward and downward. So, there were 2 motions, you are actually at the base location, you move upward first and then you rotate, okay. So, that way you can actually connect one input to the 100 outputs. So, first digit is used for the upward movement, second digit is used for the lateral movement or the horizontal thing. So, this particular shaft was typically having a gear drive, so this shaft itself can move up and down by using similar ratchet wheel kind of motion. So, backward and forward, so there are 10 locations to which it can move. So, instead of the arm, now we put a gear and then make this motion possible, and second one is this motion, which is again similar kind of arrangement. So, with the first pulse you do a vertical thing, in second pulse you do a circular horizontal thing. So, this was a 2 motion selector. Basically using these 2 components in relays, Strowger was able to build up the basic exchanges, which because of the privacy reasons actually took off, and that is the reason why Bell Labs at some point of time bought the patent in a huge amount of sum. And of course, you will have problems also. One more innovation which was done by him was something known as common control system. So, the control circuitry which is going to control this can be shared across multiple of these elements. That was the innovation which was there, which reduced the cost. Otherwise, you have to build up a control system for each one of these elements if you are putting large number of them in the system. So, common control was the innovation which was involved, which actually reduced the cost drastically, and of course maintenance wise also, because more the mechanical components, more the failure will be there, more you have to keep track of them, okay. So, whenever the mechanical failures will happen because of wear and tear, you have to replace those components. And of course, there was actually many kind of circuits which were built, which were available. I am just going to list all these. So, they have been in use in circuit switching systems in similar form, and ultimately they actually have been transformed into something equivalent when we come to voice over IP telephony. Okay. But we will not be talking about voice over IP telephony in this course, but at some point of time in the part 2 of this course it will be coming up. So, currently I am actually worried about only the how the switches are implemented, the basic theory about it. So, there was a impulsing circuit which was done. So, this used to create the power, because the whatever small short pulse which is electric current which is coming, it only signals that there is a one which have been dialed or two has been dialed. It has to be now converted to a power impulse which can drive the electromagnets. So, there used to be a impulsing circuit for that. There was a homing circuit. So, once the call is over, so you have put all your headsets back to the cradle. In that case, these devices should go back to the home location. So, that when the next set of dialing will happen, it should connect correctly. Okay. There is no memory, it has to be reset back to the home location. So, this 2 motion selector has to come down and it has to go to 0 0, it has to go to 1 1 location. Just before that there is a home location, it has to go to that. So, that when you dial the pulses, it will again connect to the right output port. So, there was a homing circuit which was there. Ring trip circuit. Remember, there is an automatic exchange when you are connecting a ringing current to the phone, destination phone. When the guy lifts the handset, earlier time there was some person who can actually disconnect the ringing current. So, at your phone will stop ringing and then you can talk. Now, this has to be done automatically here. So, for that there was a ring trip circuit. There was alarming which was for maintenance purpose. So, this also has gone through its own evolution. There was a guarding. So, you should not get into abnormal states in the switch, and of course, the metering thing. So, normally for metering there used to be an oscillator which is generating pulse periodically, and there was a counter. So, whenever the call is on, that time that oscillator is being connected to the counter. So, that rotary counter will be counting. So, there used to be dials for everybody, for every user there used to be a dial for how many seconds the call has been made, and depending on whether you are making a local call or a STD call, the oscillators will be different. So, for a STD call, the oscillator will be oscillating at a higher frequency, so the counter will move faster. Okay. So, this is the reason why in earlier days in the BSNL you used to have, there is a one pulse, 1 unit for 5 seconds, 1 unit for 1 minute, depending on the distance of the calls which was there. Now, of course, because of the electronic systems and we are using exact time, and we can actually write a software by which we can estimate the bill. Earlier days this was not possible. Only these meters actually were being recorded, what was your last reading, what is your current reading, and based on that a bill was generated. Okay. So, per unit the cost is going to be same, it will not change. Only thing that per minute how many units will be counted, that will change depending on the distance. So, that was done through the metering circuit. So, that is how this whole crossbar kind of systems, this Strowger systems used to work. But there used to be a very fundamental problem. This is a mechanical system, lot of moving components, lot of wear and tear. So, maintenance was a big problem, especially in large exchanges, and maintaining trained manpower and everybody is a big headache. Okay. And you need very good quality material to build up the contacts, and there used to be oxidation, there used to be a dirt, which ultimately these were not very much preferred. So, over time people decided we have to do away with these Strowger exchanges. In fact, now they are out of service almost from everywhere, and people moved on to something called crossbar. So, in the next lecture we will be now looking into the crossbar systems, how the crossbar technically is built, and how it is being operated, what is the algorithm by which you operate that crossbar. And then we will look into how this crossbar can be, what is the limitations which happens on the crossbar in terms of the size. Can I actually have any number of crossbar size which is possible? So, we will look into that in the next lecture.